Hey guys, let's discuss new problem from binary search. Okay, and the problem is median of two sorted arrays. So you have given two sorted arrays and you need to find its median. So those arrays are sorted itself, okay, but not relatively sorted. For example, you can see 8 here and 7 here. Okay, so they are not sorted relatively, but they are sorted themselves. Okay, so what you need to do first, you need to so here we will be using in place sorting only. Okay, we will not use extra space. See, in extra space, so it is very easy. You take extra array and just put the elements in their order. Okay, but here we don't need to use extra space. So what you will do, you will use here in place sorting. So let's say you create two halves, okay, left half and right half, and somehow you able to find that you will take first three element from array 1 in left half, okay, and then remaining in right. Okay, same, if 3 is here, it means that you need to take 3 element from array 2 also, right? Initial 3 elements, 7, 11 and 18. Okay, and then the remaining 7 and 11, not 18. Okay, means 5 here, 6 there, because total 11 elements are there. So 5 here, 6 there. That is how you found. And then 7, 11, then remaining will be in array 2, 21, 25. Okay, so now it is sorted. If you see, so 1, 3, 7, 8, 11. Okay, now it is sorted. And let's say this element is from array 1. Okay, this one is from array 2, this one is from array 1, this one is from array 2. Okay, so can I say this L1 and this one R1, and this is as L2 and R2? And you know that L1 is less than R1 and L2 is less than R2, because this L1 and R1 is from same array. So you took first 3 element in left side and remaining in right side. So definitely L1 will always be less than R1, and similarly for L2 and R2 also. Okay, so and how you will find this, that I need to take 3 element from array 1 in left side and remaining there. So it is very easy. You just apply binary search, okay, on array 1. Why array 1? Whatever is lesser value, you just apply binary search on that. That's it. Why you are doing that on lesser value? Because see, the size of this array 1 is 5 and here it is 6. Okay, the size is 5 here and 6 here. So if you apply binary search on a smaller one, the logarithmic complexity will be smaller only. Okay, here it will be log 5 and here it will be log 6. So why to apply binary search on bigger array, right? Once you know that you will you can put 3 element in array 1. Okay, so it is understood that remaining from array 1 will go to right hand side. Okay, and if let's say total element is n1 plus n2, which is 11, right? So 11, if total element is 11, okay, and you know that 3 element you will put in left. Okay, so 11 so 11 3 element you will put in left and remaining will go in right. That is for sure, right? So 2 will go in right. So left may 3 element and right may 2 element from array 1. Okay, and total element is 11. It means 11 by 2, half element will come here, right? So 5 will come here and 6 will come there, go there, right? So 5 may say 3 to already there. So you take 2 elements from array 2 here, okay, and then remaining 4 elements from array 2 here. So this is how you will, that's why you will apply binary search on a smaller array, and you will find out that how many number of elements you need to put in left hand side. And how you will do that? So you just find the mid value. Okay, one more thing, can you see here? So I told you that that L1, okay, here if you see, L1 will smaller than R1 and L2 will smaller than R2. Okay, this one is for sure. So I will check my array which I have segregated. I'll check if this condition is true, that means okay, it could be sorted. But one more thing I need to check, and which is this diagonal thing, right? L1 R2 and L2 R1. See, L1 is coming left hand side. Okay, so this one will be smaller one, so this one will always be smaller than R2. Okay, and L2 is coming left hand side, so this one will always be smaller than R1. If this condition is satisfied, then you can say that you have segregated the arrays rightly. Okay, left hand side all the smaller values are there, right hand side all the smaller greater values are present there. Okay, now if you're able to find this one, it means that see, on array 1, okay, array 1 is 1, 3, 8, 9, 15. You apply binary search left, and this is high, low, high, mid will be this one. You check for this one, means all the element which is before mid, okay, means this 2 element 1 and 3, you put that in left. Okay, remaining element in right. Similarly for R1 and R2 also, you figure out that how many elements will come here, right? If this condition is satisfying for this one, it means that you stop there and this is your array, correct sorted array. If it is not happening, okay, and if some lesser value is coming, or greater value is coming. So just adjust your left and high, low and high. Okay, so your let's say your low will become this one. Now again you will check for this one will be your new mid. Okay, now check for this 3. So this 3, what we did, 1 3 8 from L1. Okay, so remaining in right, and similarly if 3 element came in left and total element size is 11, so 11 by 2, 5 and 6, you will segregate 3 already there, so 2 element will come from R1 right hand side array, means array 2, and there 4 element will come. Okay, so see here you can see that 8 is less than 18 and 11 is less than 9. No, condition is false. 7 11 is less than 9. This condition is false, right? So you will adjust your mid. Okay, once let's say once you find the correct elements. Okay, so 7, so now you will check for 9, so 9 will come here and then this 11 will go there. Okay, this so here 11 will come and this one will become your R2. So now 8 is less than 11 and 9 is less than 15. Okay, this one will be your R2. So once you find this correct segregation, okay, now how you will find the median. So for median you have two formulas, one for even length of array and second one for odd length of array. Okay, total elements. So can you see one thing here? If I sort these two arrays, okay, what will be my array? 1 3 7 8 9 11. Okay, after that 15 18 19 and then 21 and 25. Okay, this one will be my array, sorted array. And if I write its index 0 1 2 3 4 5 6 7 8 9 10, so I have total 11 elements, 0 to 10. Okay, so what will be my mid? Mid will be my 11, means 5 element will go here, and then this 6th one will be my index 6, whatever I have will be my median. So 15 will be my median here. Okay, but let's see if you have 26 also here. Okay, and okay, let's talk about this one only. So I'll make one cut here. Okay, and then with that cut you can say that this is your left side and this is your right side. Okay, and if the element is odd number of elements, total n1 plus n2 is odd, in that case your answer will be maximum element from left hand side array, right? This one will be, so this is the last one, na? So this one will be the maximum one. But left hand side array you have two elements, L1 and L2. So this one could be your last one and this one could be your last one, L1 and L2, right? So you will find among L1 or L2, between L1 and L2, whatever is the maximum will be your answer, median. Okay, this is the case when n1 plus n2 is odd. Now what happens if it is even? See, if it is even, in that case, let's say you have 26 also here. Okay, 11. So in that case you will cut, you'll make 1 2 3 4 5 elements gone from here, 1 2 3 4 5 elements gone from here. So now you have this 11 and 15. Okay, so you will find 11 plus 15 divided by 2, and whatever will be answer will be your median. But how you will find this 11 and 15? So you will not make cut here. Okay, this is just for our understanding. You will make one cut here. Okay, and this one will be your left side, this one will be your right side, and the maximum element from left hand side and minimum element from right hand side. Okay, you will just find mid of that. How you will find maximum element from left hand side? That could be L1 or L2. Okay, so whatever is maximum between L1 and L2 will be your max element from left hand side. Similarly for right hand side, whatever is the minimum among R1 or R2 will be your right hand side element, and then you just find the mid of that. Correct? Okay, one more thing. So you know the formula, right? So for this is very simple. You first need to segregate left and right side, okay, using that pointers, and then just check if it is the even number of elements, then apply the formula. Otherwise odd, for odd a different formula, right? And just return that median. So can we see the code? Okay, let's say what is happening. See, first one, what they are doing, they're finding which one is smaller. Okay, if array 1 is smaller, then they are taking array 1 in the second position. Okay, initially first one. So first, so they swap it. Okay, they find the n1 and n2, which is the length of array 1, array 2. After that, they find, so for first one only, right, the smaller one is the first one. So they apply binary search on for low and high for array 1. Okay, so 0 will be your low and n1 will be your high. Now here they are applying binary search. Okay, your cut 1 will be low plus high divided by 2. So for array 1 is 1 3 8 9 15. This one is your low, this one is your high. So low plus high divided by 2. So this one will be your cut 1, 8 will be your cut 1. So what is the meaning of 8 cut 1 is that how many elements you have before this cut 1 will go into left side. Okay, so how many element will come into cut 2? You just calculate it, n1 plus n2 plus 1 divided by 2 minus, yeah. So guys, see, let me write it once again for the good understanding. Okay, let's say you have divided the array. Okay, means you're applying binary search on first array 1 3 8 9 15. This one will be your low and this one will be your high and this one will be your mid, means cut one. Okay, mid one, cut one, you can say anything. So means all the elements before this cut one will go into left side. Okay, so you have two sides, left side, so 1 3 will come here. If 1 3 is coming here, then 8 9 15 definitely will go in right hand side. Okay, and then how many elements left in left from right hand side? From array 2, how many elements you will take? So it's just see 5 elements from array 1 and 6 elements in array 2, so total I have 11 element. 11 by 2 means 5, right? So total 5 should come. So 5 में से 2 तो already there, so 3 element you will take from array 2, right? So 7 11 and 18 you will take from array 2, and then remaining will go into left right hand side part, 19 21 and 25, right? And this one will be your L1, this one will be your L2, similarly R1 R2. Let's check the condition. L1 is less than equal to R2 and L2 is less than equal to R1. Why we are doing this? You understood, right? Because L1 is already less than L2, R1, because they are part of one array only, same array. But you just need to find that whatever segregation you did, okay, is correct. Means all the elements in left hand side is lesser than all the element in right hand side. And for the shortcut is that just equate L1 and R, because all other elements are sorted now after that. So after R1 all other elements are sorted, R2 after all other elements are sorted. So if they are true for R1 or R2, so they are true for all other elements after that, right? So you check these conditions. So okay, 3 is less than 19, condition true. 18 is less than 8, condition false. Okay, so you need to adjust your mid, correct? So now, because see, now check what condition is incorrect. 18 is less than 8, it means 18 came in left hand side, but 18 should be right hand side, right? It should be right hand side. It means that if 18 is right hand side, so you will your low should be mid plus 1. Okay, so if your left one is greater than right 2, so this is the else part, right? Low will be cut 1 plus 1. So this one will be your low, new low. Okay, so this is not your low, this one will be your new low. And let me remove this because we will create once again. So this one will be your new low and this is your high. So mid will be now this, it will point to 9th element. So 1 3 8 will come from left hand side, and then 9 15 will go into right hand side. Remaining element 7 and 11 will come from array 2, and then 18 19 21 and 25 will go in right 2. This 25 was from here. Okay, it's just the spacing issue. Okay, now now check. 8 is less than 18, condition true. 11 is less than 9, condition false. Okay, condition false again. So again you will 11 is less than 9 means L2 is less than L2 is less than R1, condition this one. Okay, low will be cut 1 plus 1, so again low will become this. Now check once again. So now you have low and high pointing to 15, so your mid will be 15 only. So now you will have 1 3 8 and 9 this side. Okay, and then 15 this side, and from here from array 2 you will have 7 here, and remaining 11 18 19 21 and 25 this side. Okay, 9 is less than 11 and 7 is less than 15, condition true. So this is my array, and now I will find this is my L1 L2 R1 R2. Okay, so I will apply this formula because my N1 plus N2 currently my N1 is 5, N2 is 6, 5 plus 6 11, which is odd, right? So my answer will be whatever maximum value I have in left 1 left 2, so my answer will be 9 here. Okay, let's say if you have 26 also, then you will apply this formula, max value from left hand side and minimum value from right hand side. Why? I told you that, right? If the numbers are odd, then so you will find you will make one cut, and left hand side whatever is maximum value you will return that, and that maximum could be among between L1 and L2. If it is not odd and if it is even number, then you will make one cut, and maximum value from left hand side and minimum value from right hand side you will pick. But left hand side maximum value could be between L1 L2, and right hand side minimum value could be R1 R2. So that is what we are doing. You're finding max value from left 1 left 2 and minimum value from right 1 right 2, and then you're finding the median of that plus and divided by 2. Okay, so that's it. Thank you.